Hi, my name is Jen. I'm here to show you something that will explain a mistake that I believe I found in Einstein's theory of relativity. Einstein's calculations for the theory of relativity were based on a situation where there was a train car, which we'll represent with this box, an observer in the train car, a mirror on the floor of the train car, an observer outside of the train, and a light source at the top of the train pointing downward, which you will have to just pretend is there. In this scenario, the train car moves super fast, approaching light speeds. The train car is at this position when the source of light shoots a beam of light. By moving quickly, the beam of light does not hit the mirror on the floor until the train car has traveled this far. The light from the light source to the mirror would appear as a straight line from the light source to the mirror to the observer in the train car. To the observer outside of the train car, the light source emits the light here, but the light hits the mirror clear over here. As you can see, the light beam from the top of the train car to the mirror is a different size than from the light source original position to ending position. To Einstein, this difference was explained by a difference in time between the two observers. Mathematically, Einstein was correct. Einstein was a mathematician, so his theory of relativity would work out if the scenario was correct because of his math being correct. However, the scenario is a scientific scenario and the science is flawed. As we know, light is made up of a beam of particles of energy. We're going to use this bead to represent one photon, or one of those beams of energy. If this bead represented an object, like an apple, the science would be correct. Both observers would see the apple drop from the ceiling of the train car and travel with the train car and reach an endpoint. However, light acts differently than an object. This photon would not be affected by the motion of the train car. The person in the train car would see light that traveled in a straight line to the mirror as the train car traveled. However, the observer outside of the train would see light travel in a straight line in relation to this observer. Therefore, when the light source pointing straight down at the top of the train emitted this photon and the train moved away, this photon would still travel on a straight path downward in front of this observer. The possibilities that this new scenario create are amazing. There could be light spectrums that are invisible to us, which would create dimensions that are invisible to us. These possibilities are explored in our first book of the Timekeepers series, Pieces of the Puzzle.